Let's solve few problems based on the concept whatever we have learnt. Okay, look at the first one. See, we have an experiment which involves rolling a pair of dice and recording the numbers that come up. Describe the following events. So A is given. The sum is greater than 8. Second, 2 occurs on either die. Next one, the sum is at least 7 and a multiple of 3. Which pairs of these events are mutually exclusive? So first we need to define what is A, what is B, what is C, then figure out which is mutually exclusive. Okay, first let's write down the sample space. See, sample space is going to be, so the first one, S is going to be, now we are going to have 36 possibility because rolling a pair of die or rolling a pair of dice. See, we are going to have 1 comma 1, 1 comma 2, 1 comma 3, so on and so forth till 1 comma 6. Next 2 comma 1, 2 comma 2, so on till 2 comma 6. Correct? And here we have so on and so forth till 6 comma 1, 6 comma 2 till 6 comma 6. So we are going to have 36 different possibilities. Let's look at what is A, what is B, what is C and everything. Alright. Now my A value is going to be, what is the question? The sum is greater than 8. See, if sum has to be greater than 8, we'll start by taking 3. Okay, so that is, see, we can start by taking 3 comma 6 because 3 plus 6 is 9. So the first value is going to be 3 comma 6. The next one, see, can we take 4 comma 4? No, because 4 comma 4 is 8. The question says greater than 8. Isn't it? 4 comma 3 not possible, 4 comma 4 not possible. That means the next one has to be 4 comma 5 and 4 comma 6. Correct? Now the same thing if you look at 5. So 5 comma 4, 5 comma 5, 5 comma 6. Correct? And then finally in this case, so 6 comma 2 is 8. So we start by taking 6 comma 3, 6 comma 4, 6 comma 5 and 6 comma 6. Right? So the sum is greater than 8. We have so many possibilities. So this is the answer for A. Okay. Now we'll look into the value of B. See, for B, what you have is 2 occurs on either side of the die. Correct. So we can start by taking very simple 1 comma 2. Correct. Or 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5, 2 comma 6. The entire row of 2, isn't it? And also the entire column, which is 1 comma 2, 2 comma 2, then 3 comma 2, 4 comma 2, 5 comma 2 and 6 comma 2. See, these are the possibilities for B. Fine. Now we'll do for C. Look at C. The sum is at least 7. That means it is 7 or greater than 7. That's going to be 7, 8, 9, 10, 11, 12. Isn't it? And a multiple of 3. So there is a condition. Isn't it? First, sum has to be 7. Correct? First, what we'll do, we'll write down the numbers. Or you can directly do it. Okay. Now, sum has to be at least 7. So 4 comma 3, 3 comma 4. Two of them. Isn't it? So first is going to be 3 comma 4, 4 comma 3. But it says sum is at least 7 and a multiple of 3. So can we take 4 comma 3 and 3 comma 4? No, correct? So since it's a multiple of 3, it has to be 9 or 12. Isn't it? So what we can do, we can eliminate this 4 comma 3 and 3 comma 4. The sum has to be 9 or 12. 9 we can get from 3 comma 6, 6 comma 3, 1, or 4, 5, 5, 4. This is for 9. And for 12, only one, which is 6, 6. Isn't it? So these are the values for C. Fine. Now look at the last one. Which pairs of these are mutually exclusive? Isn't it? So if you remember A, B, and C, between A and B, do you have anything common? Check. Anything common? You don't. That means A and B are mutually exclusive. The reason is A intersection B is null set. That's why. Same thing, B and C also you don't have any common factors. So A and C are also mutually exclusive. Fine. So all the three are mutually exclusive to each other. Fair enough? Now let's do the second problem. Look at the second one. 3 coins are tossed. Describe 1, 2, 3, 4, 5. There are 5 sub questions. Correct? See, the first one, what we'll do is we need to write the sample space. That has to be your first step. Okay, so sample space S is going to be, so you have H, 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 T, then H, T, H, H, T, 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 H, H, T, H, T, then T, T, H, then T, T, T. So there are 8 possibilities for this one. Now we'll start with the first one. So the first one, 2 events which are mutually exclusive. Now if you take event A to be, let's say, H, 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 and event B to be T, T, T. Do you see anything common here? No. Correct? So A and B are mutually exclusive because it is 5. Okay, so we found the 2 events which are mutually exclusive. Correct? Now the second one, 3 events which are mutually exclusive and exhaustive. Consider 3 sets. Okay, so let's say we'll name it as say PQR. It's easier to take PQR. Say you're going to take P. See, let P be equal to, we have HTT, TTH, and THT. Assume that these are the 3 parts, or you can say 3 elements. Then we have Q. Q is going to be one more set. So Q is going to be HHT, HTH, THH, and HHH. Okay, and since they're asking for 3 events, we'll take one more. Say R is equal to TTT. Okay, now see 3 events which are mutually exclusive and exhaustive. Exhaustive part we can easily do because P union Q union R, it's going to give you the sample space S itself. Look into that P union Q union R. It's going to give us S. Right? Now what we'll do, we need to show that they are mutually exclusive. Right? So if you look at P intersection Q, okay, P intersection Q, look at the values. HTT, do you see HTT anywhere in Q? No. Or TTH or THT for that matter? No, right? So we can say that P intersection Q is going to be a null set. Correct? Same way Q intersection R is also a null set, isn't it? So what we can write? P intersection Q is a null set. Q intersection R is also null set. And same thing, P intersection R is also null set. So all 3 are mutually exclusive, but P union Q union R is equal to S, correct? So P union Q union R is equal to S. So they are exhaustive events too. Fine. So the second one, we proved the second. Let's go to the third one now. See, for the third sub question, see what we can do. You can take 2 events. Say A is HHH, HHT. And let's take B to be HHH. Now A intersection B is not equal to null set, isn't it? We have a common element HHH. So we got two events which are not mutually exclusive to each other. Very, very simple, isn't it? Now what we'll do, we'll look into the fourth one. See, two events which are mutually exclusive but not exhaustive. Guys, I think we can take the same example what we did took for the previous one. That is, take A as the same thing. That is HHH, HHT. If you want, you can also add HTHT. Okay, which are mutually exclusive, correct? So let's take this one to be TTT. Now, they are mutually exclusive, correct? So A intersection B is equal to phi. So they are mutually exclusive. But is A union B equal to S? Is it? No, right? Since this is not equal, we can say that it is mutually exclusive but not exhaustive. Fine. Now let's do the fifth one. Say the three events for the fifth one. Let there be P, which is say HHH, and say Q, which is HTH, and R, which is say TTT. Alright. Now, if you do mutually exclusive, obviously looking at this only, you can tell that they are mutually exclusive, isn't it? Because P intersection Q is a null set, Q intersection R is a null set, P intersection R is a null set, correct? But P union Q union R, is it equal to S? No, this is not equal to S. So three events which are mutually exclusive but not exhaustive. So you can take these three as an example. Again, your answer might be different from my answer. It's not about the answer, it's actually about what type of set you're choosing. That's all. Fair enough? So now let's do the third question. See the third one? A die is rolled. Let E be the event where the die shows 4. Correct? So E is an event where the die shows 4. F be an event where the die shows an even number. Are E and F mutually exclusive? Right? Very simple question. See, E is an event. One die is rolled, correct? When one die is rolled, E is going to be 4. F is going to be where the die shows an even number, which is 2, 4, and 6. Isn't it? So what is E intersection F in this case? E intersection F is 4. Since this is not a null set, we can tell that E and F are not mutually exclusive. Are not mutually exclusive. Clear? So this is going to be the answer for the third one. Now let's do the fourth one. See the fourth one. See in the fourth one, two dice are thrown. Events A, B, and C are as follows. So first let's do the S value. Guys, I think it's easier if we write all 36 together. Okay, all 36 possibilities, whatever we have. See, this is going to be, first I would say this is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Like this, we'll have to fill up the whole table. There we have the complete data, right? Now let's start with A. What is A? Getting an even number on the first die. So let's mark the numbers. Even number on the first die. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's basically 18 are there, correct? So we can mark all 18 of them, isn't it? So here we are going to have, so 2 comma 1, 2 comma 2, 2 comma 3 till 6 comma 6. Isn't it? Whatever you see in the blue marking, there are all the cases which is going to be the answer for A. Correct? Now we'll do for B. See, what is B? Getting an odd number on the first die. Guys, don't you think it's the same? As in, instead of 2, 4, 6, we have 1, 3, 5 now. Isn't it? This. So again 6 here, again it's going to be 6 here. So totally there are 18 values, or you can say 18 elements, which is going to be the answer for B. Correct? Now for C, getting a sum of numbers on the dice less than or equal to 5. Correct? See, getting less than or equal to 5, that's going to be 1, 2, 3, 4. Obviously, the other two is not possible. Next, 1, 2, 3. Next, 1, 2, and 1. So that's basically this entire part of the data. See, like this much. This data, what you see here, these are all the numbers where the sum is less than or equal to 5. Correct? So we have 1, 2, 3, 4. 4 plus 3 plus 2 plus 1. That's basically 10 values are there. Fine. Now let's do the next one. Describe the events A complement. Right? See, A complement is nothing but, see, A is what? Getting an even number on the first die. What is B? Odd number on the first die. Don't you think A complement is nothing but B itself? Correct? So those 18 values, whatever you have written, that is nothing but A complement. That is the answer for the first sub question. Very simple. Second one, not B. See, not B is nothing but A itself, isn't it? So not B is going to be nothing but A. So A complement is B, not B is nothing but A. Okay. Now A or B. Guys, A or B is nothing but the entire sample space. Because A is what? All even number on the first die. We have 18 numbers, isn't it? All odd numbers, we have 18 values. When you take A or B, you are going to get all 36. Isn't it the entire table itself, whatever you are seeing on the screen? Correct? So A or B is the entire sample space. Next, A intersection B. See, when you have A intersection, because A and B, do you have any common value between them? Nothing, right? Because one is odd number first, one more is even number first. So there can never be a common between them. So A in and B or intersection is going to be 5, which is a null set. Alright. See the next one, A but not C. See, A but not C in the sense nothing but things which are in A but not in C. Correct? Things which are in A but not in C. So what do we have? A is what? In even number on the first die. So I cannot choose this, this, this. And I cannot choose this. Isn't it? Because things which are in A but not in C. So what are the values now? 1, 2, 3, 4, 5, 6, 7, 8. And here all 6 of them. Correct? So these are the values for A but not C. That's 2, 4, 2, 5, 2, 6, then 4, 2, 3, 4, 5, 6, 6, 1, 2, 3, 4, 5, 6. All of it. Fine? This is the answer for the fifth one. A but not C. The next one, B or C. B is what? Getting this one, odd number on the first die, which is basically this list this list, and this list. And what are the common things for this one? That is, what are the values for C? For C, we have, of course, we are going to have these four. We have till here, and we are going to look at this entire part, isn't it? So when we write B or C, we are going to have quite a big value because 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4 is common. 3 comma 1 is common. You don't have to write it. But what are the extra terms what you are going to get? The extra terms are 2 comma 1. See, you're going to get 2 comma 1, 2 comma 2, 2 comma 3 and 4 comma 1. These are the extra terms what you are going to have in that B or C. Fair enough? These are the values. The last one is what? B and C. See, for B and C, again, so we are going to look at these values, isn't it? What are the common ones? 1, 2, 3, 4, 1, 2. Correct? So for B and C, you're going to have 6 values. That is 1 comma 1, 2, 3, 4 and 3 comma 1, 3 comma 2. Fair enough? So these are the values for B and C. Fine. So whatever we have studied so far, complement, union, intersection and one-sided, that is belonging to one, not belonging to other. Or we also did that mutually exclusive and exhaustive events. We have covered all the types of problems what you have learned in the previous part. All right. So the next part of the probability chapter, we'll look into that in the next video.